Anybody else tonight? You guys have mom? Julia Freak, you're kind of watching. Translation is not Vegas.
Okay, so these are called two-color counters. Pretty self-explanatory. They're counters, and they come in two colors. One side is red, yellow. And so we use them with little kids just really for counting and making arrangements of dots and things like that. So if you look at what I have up here, if you look at these three different sets of counters, how many are in each set?
4.
4. Which one was the easiest to say it was 4? Top corner. Why?
Because it looks like a die.
Because it looks like 4. You're used to this one, right?
Yeah.
And you're not as used to the other 2. And so what we call this is we actually call it subitizing. You'll hear that as a fancy word. Okay, so it's called subitizing. And it's basically what we want is for kids to be able to recognize familiar arrangements of dots without counting. So that top one that you said, that was easy. You knew it was 4 right away. Okay? That's a familiar arrangement, so kids can subitize that really quickly, mostly because they play games and stuff, right? Like you play dice and you'll see it in the dice patterns. Dice patterns are the easiest ones for kids to learn. But it is important that they can kind of look at the other ones and quickly get those too. Okay? Which one do you think is actually the hardest to notice right away that it's 4?
The T.
It's a line.
I think I would argue the line too, just because the T you can kind of see 3 and 1 and get 4. But the line you kind of have to do a double check. There's a piece article that I read actually, and they said try and visualize in your mind like 6 counters. So if you closed your eyes and you wanted to visualize 6 counters, what's the arrangement that you see?
3
and 3. Mm-hmm. Try to visualize 6 counters all in a line. It's hard, isn't it? Right? And if I said, okay, visualize 7, what would you do for 7?
4 and 3.
You might do 4 and 3. You might do 6 and 1, right? You might do 5 and 2. But chances are you're organizing them visually in some way that helps you, and it's often based on those dice patterns, right? Or 10 frame patterns if you've had a lot of experience with 10 frames. When I visualize 7, I see it in a 10 frame in my head. We're going to look at those. So we want kids to be able to subitize. We want them to be able to see a number and say it. So what are all 3 of these numbers? 7. Okay? But we can talk about them when we look at these patterns, these dot patterns. We can say, well, the first one I could see it as what? 6 and 1. So I could actually say this one shows me that 6 plus 1 is 7, right? And the other one is the next column. 5 and 2. Okay, so 5 and 2 is equivalent to 7. And this one would show me that 7 is equivalent to 4 and 3. Okay? So again, recognizing numbers, recognizing quantity by looking at familiar arrangements, that's subitizing. Often in grade primary, we do a lot of work with like holding up dot cards. We do. Did anyone see in a grade primary class that you get the plates with the dots on them, and you hold up the plates? Like a lot of teachers will take like paper plates or plastic plates and do dot numbers with them, and so they do dot frame flash basically. So you might have 5 dots on a plate or 6 dots on a plate, and you hold them up. The kids have to say quickly. That's what we do for mental math really in primary. Towards the end of primary is doing 10 frame flashes, dot plate flashes, and things like that. So we want kids to get a visual sense of number. We want them to be able to hold that quantity. And that's going to help them with counting on, right? So if I see that 5 and 2, as soon as I see that 5, if I have to add that, I can say 5, 6, 7, hopefully, rather than having to recount them all, right? And that's one of the reasons why we're doing all these, like, dot frames and dot cards and all that kind of stuff, is to help kids to get that visual. And all of that stuff is going to contribute to the conserving number, the counting on, because it's a big, big piece. And I know we talked last day, like some people were seeing even in their grade 3 and 4 class, kids who were starting back at the beginning to count, right? And we want them to have lots of experience of seeing counters and arranging them in familiar ways so that they get used to visualizing them. So that helps them to get into that notion of counting on and conserving number and all that kind of stuff. Okay? And we also want them to see that if I switch the dots around, the quantity still stays the same, right? These are 3 different arrangements of 7, but they're all still 7. Okay? And that's one of the important principles of counting is that you know, even if I move stuff, it's still 7. You'll see really young kids, you give them something and they count it, and then you move them around, and you say, how many now? You didn't take any away, and you didn't add any new ones. They still have to recount because they don't have that conservation of number yet. But when we do different arrangements that show the same number, that helps to build that conservation. They know, hey, even though you moved it around, it's still 7. It's okay. All right. And then we start to use 10 frames. Okay? So this is basically how we use the 10 frames. We start with 5 frames typically. We might do things on the 5 frames like what is 3 and 2 and you get 5, or how many more, if I put 2 on here, how many more do I need to make 5? We'll look at those in a minute. But we use the 10 frames really, they show us a lot about the relationship between numbers. So one of the important numbers that we want kids to learn is 5 and 10, right? Because those are what we call benchmark numbers. And we call them benchmarks because they're easy to work with, right? So we like to find 5s and 10s in our calculations because we often find that easier to work with. And so when I look at 8 in the 10 frame, I see that 8 is 5 and 3 more. It's 3 more than 5. It's close to a benchmark number, right? It's closer to 10 though, isn't it? How do I know 8 is closer to 10 than it is to 5? Yeah, because I only need 2 more. If I wanted to fill in the spaces, I need 2 more to make 10, right? So I can say that 8 is 2 away from 10. And so when we use the 10 frame, we're not just teaching kids about the number, but we're teaching them about how the numbers work together, okay? So we're teaching them about 8 being 5 and 3, 8 being 2 less than 10, and so we're establishing relationships between 8 and other numbers, okay? And that's important. We want kids playing with 10 frames a lot, modeling numbers on 10 frames a lot. Now, I've loaded them a very specific way. Sorry, my computer is logged into my Dropbox and people keep loading things in there. So I've loaded them, I put the counters on a very specific way. I put the top row in first, and then I added 3 more. Sometimes when you first give these to kids, they'll make 8 like this. Okay? And that's fine, right? It shows that 8 is 4 and 4, and some kids like to load them in pairs, and then you can talk about, yeah, if you can load it in pairs, it's even, and you can't, it's odd, right? Things like that. So it's okay for them to do that, but we do encourage teachers to model filling the top row first, because then you're filling in things in order. So you're going 1, 2, 3, 4, 5, 6, 7, 8, right? So we do encourage teachers to model it this way, although students should be able to recognize that both arrangements are still equivalent to 8, right? Similar to the 10 frame. And when we get into the bigger numbers, it's actually easier to subitize with a 10 frame because you can quickly recall it, and it's more easy that way, I find. It helps kids to develop a visual. And we want them to have lots of visuals. Okay? And we even do things like showing equivalence. The team numbers are really hard for a lot of kids. They're weird. I don't know if you've ever thought about it, but let's take a moment to think about it. 21, 22, 23, 24, 25, 31, 32, 33, 34, 35, 41, 42, 43. Nice pattern, right? 11, 12, 13, 14, 15, 16. It's the only set of numbers that doesn't follow that pattern of the 10s and the 1s, the 10s and the 1s, right? 21, 31, 41, 51. We don't say 10 and 1. Some languages around the world do, right? Some languages around the world, actually in, I think it's Chinese and Japanese, the word for 11 is 10 and 1. The word for 12 is 10 and 2. And there's actually some speculation that it's much easier to learn to count the teens. In the literature, they talk about that. It's much easier to learn to count the teens when it follows that nice pattern. In English, it doesn't follow a nice pattern, and the teens are actually some of the hardest numbers to learn because they break the pattern. They're weird. And the reason they're called 11 and 12 and 13 is because it's a holdover from a base 12 system. But we want kids to realize that 14 is a set of 10 and 4 more. We want them to realize that 17 is a set of 10 and 7 more. So with the 10 frames, we can do that, right? We get comfortable with the 10 frames. And then later on, we can do really fun things like showing that if I have to add 9 plus 5, I can add 10 plus 4 instead, right? And that's a strategy that we learn in grade 2 in mental math. And it's basically based on a make-10 strategy. So take 1 from the 5, give it to the 9, and now it's 10 plus 4, which is easier to add. Okay? So a lot of our mental math strategies that we do in grade 1 and 2 hinge on kids being able to visualize these 10 frames. So our grade primary students need to have lots and lots and lots of playing with 10 frames and 5 frames.